This video is on Unit 3, Chapter 7 on rational exponents and radical equations, lesson number 2 on rational exponents. Under rational exponents in our notes here, it says expressions with rational exponents can be rewritten as radicals using the following rules. Now, before I get to the rules, I want to refresh your memory. Your set of rational numbers, if you go back to our very first lesson that we did together, rational numbers are any number that can be put into a fraction form. So what I need for you to associate here is that when you hear the word rationals, those are the same thing as fractions because it's any number we can put into a fraction form. So when we have exponents that are rational numbers that are fractions, those are going to create radicals. So those are going to, again, create those radicals. So let's talk about these rules. The first rule, when you have a to the 1 over n, that's in exponential form. That means the nth root of a. And we rewrite that as the nth root of a. So the denominator is the index. Again, the denominator on that rational exponent is going to be the index on your radical. The other rule is a to the m over n. The difference here is the numerator. So the numerator in the first one was a 1, so it didn't affect anything. But in the second one, there's an m in the numerator. So that says the nth root of a raised to the mth power. So when you have a to the m over n, where again, the denominator is still the index. So the n is still going to go as the index of the radical. The a is your base. It's still going to go inside the radical. The m can either go as an exponent on the a, or we can rewrite this as one giant radical raised to the nth power. So in this first set of examples, all we're going to be doing is converting between exponential and radical form. The directions say to write each expression in radical form, simplify if needed. So the first example, x to the 1/4 power can be rewritten as the 4th root of x. Now the numerator's a 1, we don't need to change anything. On number 2, the parentheses mean that the 15n is your base, and then 1/2, the numerator's a 1. So this is going to be the square root of 15n. On number 3, 24 to the 1/3 power is going to be the cube root of 24. Now, up to this point, none of those could have been simplified, but there is a perfect cube that's a factor of 24. 24 is the same thing as 8 times 3, and 8 is a perfect cube. The cube root of 8 is 2, and then that 3 is going to stay under the radical. If you're using the calculator to do that, simplify those radicals, those nth roots, again, you would go to the y equals screen, put in the 24 divided by x to the 3rd power, and then look at your table to find that reduced radical form. Let's keep going. Let's look at number 5. I've got k to the 7/2 power. So this is going to be the square root of k to the 7th power. Now that can be reduced because the understood index here is a 2, and you have 7 k's on the inside. So reviewing how to simplify your variables, how many of those 7 can divide evenly by 2? Well, 6 out of the 7 can divide evenly by 2, and again, we divide by 2 because that is the understood index. So 6 of those divided by 2 gives me 3. So k cubed on the outside times the square root of k. You just had that one leftover k. On number 6, 3 is your base. So the 3 is going to be inside the radical. Your denominator is 4. That's our index. And then we have a numerator of 5. So I'm going to write that 3 to the 5th power. So we can do this one of two ways. We can actually figure 3 to the 5th power, or we can treat that 3 kind of like we just did the k. So I have 5 3's. 4 of those will divide by the index evenly. So 4 divided by 4 is 1. So I'm going to have a 3 on the outside, and there's 1 left over 3 for the inside. Now, if that didn't make any sense, then you're going to do 3 to the 5th power and get 243. And then you're going to have to simplify that. So 243 divided by x to the 4th power. And you see the 3 and the 3, which is what I had a minute ago. So 3 times the 4th root of 3. All right, let's keep going. Let's look at number 8. Number 8, we've got in parentheses a negative 6x, and that negative 6x is being raised to the 2/3 power. So the denominator, again, is your index. The negative 6x is the base, and it's being squared. So let's go ahead and square negative 6x, and we get 36x squared. And then we have to ask ourselves, can I simplify that any further? Is there a perfect cube that is a factor of 36? And there is not. So that would be your answer for number 8. I want to look at number 9 real quick because this one looks a little different. We have 7 times 12w to the 1/2 power. So you have to ask yourself what's being raised to the 1/2 power. The 7 is not being raised to the 1/2 power. So the 7 is actually a coefficient on the radical. So that's what that would look like. Now, can I simplify that? Now remember the understood index here is a 2 because that was the denominator. Is there a perfect square hiding out that's a factor of 12? Well, 12 can be rewritten as 4 times 3. And the square root of 4 is a 2. So I'll have 7 times 2 times the square root of 3w. So I have for my final answer here 14 times the square root of 3w. All right, let's move on to the next section here where we're going to go the other direction. We're going to write each of these expressions in exponential form. So it's in radical form now. I'm going to write it in exponential form. On number 10, the base is 16. So I'm going to have 16 raised to. The index is a 3, so that'll be 1/3 power. And I'm done. On number 11, x and y are both under the radical. So this one's going to require some parentheses. So I have xy raised to the 1/2 power. Same thing on number 12. 8w is your base. So please put that in parentheses. And we have the 1/4 power. Let's jump to number 14. The base is k. Now notice that the k underneath the radical has an exponent of 5. So very carefully, you want to put the 5 and the 4 in the correct spots. The 4 is the index, therefore it's the denominator, and the 5 is going to be our numerator. You can put that in parentheses if you want. It's not necessary here because you have just the one single k. Let's look at number 15 though. In comparison to 14, our base is not just a single term. Our base is 3m. So I'm going to use parentheses here. We have our 3m in parentheses. The understood index is 2. So that's going to be my denominator. And then the 7 is going to be the numerator. Now, on number 15 versus number 14, the exponent, the numerator of that fraction was in two different spots, but it can be written in both of those ways. Let's jump down to number 16. On number 16, the base is negative 2a, so I'm going to write my negative 2a in parentheses. My numerator is going to be the 5, and my denominator is going to be the 4. So that's how we convert from radical to exponential. All right, let's keep going here. Simplifying expressions with rational exponents. In order to do this, we're going to have to quickly review our rules of rational exponents. So first, we want to rewrite all radicals in exponential form. Then we're going to use our exponent rules to simplify the expression, and then we're going to write our answer as a radical in simplest form, rationalized if needed. So quickly reviewing your exponent rules. If the operation is multiply, so if I'm supposed to be multiplying, exponents do not multiply, exponents will add. If the operation is divide, we're going to subtract exponents. And I should also add here that that's on like bases. We can add exponents on like bases. We can subtract exponents on like bases. Just be careful. If you have a power raised to another power, that's supposed to look like an exponent. So we've got an exponent to an exponent. You're going to multiply those exponents. And that's all I can think of as of right now. I may add to that as we go through. But basically, exponents do not follow those typical operation rules. So looking at number 19, we've got x to the 1/3 power times x to the 4/3 power. So we can rewrite this using our exponent rules. Because it says multiply, the bases are the same. They both have a base of x. So I'm allowed to add those exponents. 1/3 plus 4/3 is going to be 5/3. And then I want you to rewrite that in radical form. So this is going to be the cube root of x to the 5th power, which will simplify. 3 of the 5 will come out, so because 3 divided by 3 is 1. And then that leaves me with 2 of those 5 left inside. So there's the answer on number 19. You may have to use your calculator to do some of this with the fractions, but you do have the ability on the calculators to handle these fractions. The main thing is that you're going to need to take some time to go back and memorize and remember these rules of exponents. Number 21 is division. I have m to the 5/2 divided by m to the 7/4. Because it's divide, we are going to subtract those exponents. And again, we are only allowed to do this because they both have a base of m. So this is going to turn into m. 5/2 minus 7/4 is going to be, I believe it's 3/4. And again, I'm going to change this back into a radical, or change it to a radical. 4th root of m to the 3rd. And that's going to be as good as that's going to get. There are not enough m's on the inside to bring anything out. I want to look at 22 and 23. So on number 22, this one's easy for you because the base is an a. And this is what power raised to a power looks like. A 1/3 times 5/2 is going to give us 5/6. And then we're going to change this to a radical. It's the 6th root of a to the 5th power. And again, there are not enough of those a's to bring anything out. Number 23 is just like number 22, but it's a little confusing for you because the base is not a letter. It's not a variable. It's an actual number. You're going to leave the 32 alone, and you have to, again, remember that the rule here for these exponents is to multiply. 1/2 times 1/2 is going to be 1/4. Rewrite that as a radical, so I have the 4th root of 32. And then we got to simplify that. So the 4th root of 32 should be 2 4th root of 2, but we'll go back and we'll just quickly double check. So I have 32 divided by x to the 4th power. And there's the 2 radical 2. So 2 times the 4th root of 2. Now on number 24, I want to look at number 24 as well. Notice here you have an 8 in front of the x squared, and both of those are being raised to the 2/3 power. So the 8 is not an exponent. We're going to actually raise 8 to the 2/3 power, and we're going to take the x squared to the 2/3 power, which means we're going to actually multiply those exponents. So x squared times 2/3 is going to be x to the 4/3. And then we can reduce each little part. Or we can put it all into one big giant radical. Notice that both denominators are a 3. So we could rewrite this in radical form. Let's try that first. So it's going to be cube root. Both of them have a denominator of 3. The 8 is going to be squared underneath, and the x is going to be raised to the 4th power. Well, 8 squared is 64. X to the 4th power. And then we would just need to simplify from there. Cube root of 64 should reduce to a 4. The cube root of 64 is just 4. And for my x's, I have 4 of them inside. There's going to be 1 that comes out and 1 that stays under. So my final answer here is 4x times the cube root of x. Negative exponents, here's another one I forgot to add to the list. Negative exponents, you need to flip. You're going to think flip or reciprocal. So 100 to the negative 1/2 power. Again, we're going to have to look at this like it's a fraction, and we're going to flip this fraction. And the 100 is going to go down to the denominator, and that negative 1/2 becomes positive. So now let's look at this in radical form. I have the square root of 100, which is 10, and my answer becomes 1/10. Same thing would happen on number 27. I want to look at number 28. Number 28 has a fraction on the inside raised to a negative exponent. So when we flip this, you're just going to flip that 7 and the 1/12, and that negative 1/4 becomes a positive 1/4. 7 over 1/12, I think, is going to reduce. It does. It reduces to 1/16. And then we're going to raise that to the 1/4 power, which is the same thing as the 4th root of 1 over 16. The 4th root of 1 is 1. The 4th root of 16 is going to be 2. So our answer there is just 1/2. Now when you get down to 29, 30, 31, the rest of these, before we can even start, we need to change that to exponent form. So the cube root of v times the square root of v is going to be v to the 1/3 power times v to the 1/2 power. And then we go back and we think about those exponent rules. So we're going to add these. 1/3 plus 1/2 is going to give us 5/6, and then change it back into a radical. So that's how the rest of these are going to work. I'll work a couple more. Let's look at number 31. We have in the numerator 4 to the first power divided by 4 to the 1/3 power, and we need to subtract. 1 minus 1/3 is going to be 4 to the 2/3 power, which is going to change to the cube root of 4 squared is, let's just go ahead and make that 16. And then again, you have to ask yourself, is there a way for me to simplify that? And there is. That is an 8 times 2. So 2 cube root of 2 would be my final answer on number 31. And then, yeah, the rest of these we've done an example like. Again, when you're given radical form, change it to exponent form, deal with the rule, and then change it back to radical. So those are your notes for Chapter 7, lesson number 2 on rational exponents.